welcome everybody to today's webinar, Implementing the 5 Pillars of IT Security for MQTT. Thanks for joining us today. I am happy to present today's speakers, Magi, Erber and Georg Held. Magi is conference speaker, author, and expert for cloud-native technologies, Apache Kafka and IT security, and she is product manager at HiveMQ. I'm also happy to have Georg Held here today. Georg is software developer at HiveMQ. He's an expert for IoT and is also the lead developer of the HiveMQ Enterprise Security Extension. We will kick off in a minute, but before we start, I want to let you know that all participants are muted. However, you can ask questions during the webinar by clicking on the Q&A box in your control panel. Questions will be answered during the 15 minutes Q&A session. If there is not time to answer all of your questions, they will be answered on our HiveMQ community forum. The link to the forum will be shared with you afterwards. Additionally, we will also start a quick poll during the Q&A session and would be very, very pleased if you could give feedback on this webinar, because this helps us really to improve our webinars. So I think this is everything you need to know for now, and I am happy to hand over to Georg and Magi.
Okay, hi everybody, and thank you, Verena, for this introduction. So we are very happy here for this big interest in this topic, and we're looking forward to talk about a key concern of our company, which is security for MQTT. So, okay. As we speak, so in this moment, millions of things are newly connected to the internet. So the IoT is really a big and growing industry. And to give you an idea about how big the Internet of Things is, let's have a look about some numbers. Okay, what you can see here is the number of devices on the internet. And as you see there in 2025, there will be 75 billion devices connected to the internet, which is a huge number. If you have a look into the slide, you see at the bottom a small yellow line here. And this line is the number of people on the internet. So in comparison to the number of devices in the internet, that is huge. So the Internet of Things is really huge. Just to give you kind of an idea, the yellow line is around about 4 to 5 billion people on the internet. So in comparison to 75 billion, that is enormous. And as you also can see here, the Internet of Things is rapidly growing. So, but we have a challenge here. Web technologies that is used today is built for the Internet of Humans, so that you and I can connect with each other, but it is not built for the Internet of Things. So why? We have here typically some technical IoT challenges. The first challenge is scalability. So the common enterprise IT infrastructure and all those protocols are not made for IoT. So in the Internet of Things, usually we want to connect millions of devices concurrently. And to do that with enterprise IT, that is really a hard problem to solve. And it's even more a problem if you want to bring the data that all the millions of devices send to your already existing enterprise systems. So scalability is here the first challenge that we meet. Another challenge is instant data delivery. So especially if you think of all the services that you use, like for example WhatsApp, then you are used to have an instant data delivery, so an instant user experience. So if you send a message to your friend, then You want to that this message arrives there in the same second you write it. And the same is true for IoT use cases. And it is even more important if you have critical systems that need to communicate with each other. So real-time communication here and that around the globe is a huge problem to all the typical technologies, web technologies that were used or that are used for the Internet of Humans. And another thing, or another problem that we face here is unreliable networks. So reliable communication is especially important for business critical systems. And in an ideal world, we would have internet connection that is totally reliable, that is totally stable. But unfortunately, we do not live in that world. So we have internet connection that is sometimes a little bit flaky. And especially if you think about moving devices like cars, that becomes an even more bigger problem, because then you change the location where you are, and the internet connectivity is different on different locations. And another thing that we have to think about here is updating your devices that are out there, especially if you do not have a physical access to those devices. So that is also a thing that you have to think about, that the devices that you have out there, they are not easy to program and maintain. The complexity here for the communication must be at the broker side. I'll explain that a little bit in a minute. What is broker and client side here for all those who are new to MQTT. So, but remember this here, the complexity must be at the server side, not at the client side. Okay, so that means we need open standards that are designed for the Internet of Things and not for the Internet of Humans. And the open standard that is designed for the Internet of Things is MQTT. So MQTT was introduced in 1999 by Andy Stanford Clark and Arlen Erber, and became an official OASIS standard in 2014. So what is MQTT? First of all, MQTT is an IoT messaging protocol. And that means it is really made for communication in the Internet of Things, especially if you have unreliable networks. And of course, it is also designed for extreme scale. Okay, the protocol itself is based on a publish-subscribe architecture. We will have a closer look at that in a few slides. And it allows you to exchange data across the globe instantly. So that's what we want for business critical IoT use cases here. Okay, but talking about use cases, where is MQTT used? So MQTT is basically used kind of everywhere. So I think the most popular use case is the connected car. There we also have a lot of information on our website and also some webinars about. Then other use cases are typically IoT or Industry 4.0. That's especially here in Germany, a big thing. Then logistics, telecommunication, IoT messaging, middleware. So you can see MQTT is kind of everywhere where you want to connect millions of devices at scale in a reliable manner. So in general, where do you use MQTT? Yeah, in general, if you have some kind of push communication where you want to connect devices and have reliable communication over unreliable networks. And per design, MQTT is made for constrained devices. That means devices that have low computing power and low memory, they can use MQTT without any problems. Okay, so let's have a look into how MQTT works. So basic overview here. As I said, it is a lightweight protocol on top, a lightweight protocol for the Internet of Things, and it is on top of TCP/IP. And it basically works like this. You have this publish-subscribe pattern using topics. That means if you have a client, an IoT device, let's say here in this example, it is a car that wants to publish data to, let's say, a backend service, then the client connects to the MQTT broker, which is the central messaging component here, and publish the data to, or with a specific topic, to this broker. And the broker takes care about the communication to all the other devices that are interested in this topic. So that means the other devices can subscribe to this topic and then get the data published to them. So basically, MQTT is a protocol where you have two kinds of communication partners that are the MQTT clients, which are basically IoT devices, could be also your enterprise backend systems, but typically that are your IoT devices. And on the other hand, you have your MQTT broker as the central messaging component here. So that means you decouple the sender and the receiver of the messages from each other. Okay, so we're coming now to the security topic of this webinar. What are the typical challenges for IoT use cases that we see? So the first challenge that we see here is you have a lot of sensible data with IoT devices. So if you connect your things to the internet, then the things are starting to publish data. And it depends on the use case, of course, what kind of data this is. But let's say it is an application where the location of your family members is exposed. Then this data is really sensible, and you do not want to have that data in the hands of a stranger. So it is cool that you have the data you own, but you do not want to have it somebody else. And if that data, if you see a data breach here, then that would really damage your reputation of your business. So the bad press here could really ruin your business or business unit. And as you know, every company relies kind of on its reputation in the market. So the other thing is, or the other challenge that we see here is the control over IoT devices. Which means if you lose the control over your IoT devices or the IoT devices that are connected to your MQTT broker, and an attacker could get the control over the device, this could be extremely dangerous. Just imagine that your IoT device controls parts of your car, like the steering or the brakes or whatever, and an attacker has now the control over those things. That could be extremely dangerous. Or another thing, if an attacker has access to your device and can read all the messages that are sent via your MQTT broker, then the attacker gets access to the data that is published there and gets access to your corporate secrets, which is also not that good. So challenge 3 is legal or corporate regulations. Frequently, legal concerns or corporate compliance policies require that access to a system is restricted. And there are a lot of regulations out there, legal regulations like GDPR or CCPA, etc., that you have to be compliant to. But Okay, that really depends on your use case too, but you have to take that into your considerations if you plan your use case here. Okay, and the challenge number 4 is customer experience. So we really want that our IoT applications are usable by our customers. Although we have, or even when we have security in place here. So we have to combine high-grade security and excellent user experience. And that means also we must have a look at how to develop and maintain our devices and apps. And that is also point here that the complexity should not be at the devices that are out there at the customers, but at the broker that is under our control. So as you see, security is really a key concern for any application here. And I'd like to hand over to Georg for a technical deep dive here.
Thank you, Magi, for this great introduction. And again, welcome from me to our webinar about security. So what is the first thing you have to keep in mind if you think about security? The first thing you have to keep in mind is that you have to keep everything in mind. Security is not this simple feature you can implement, but security must be looked at in a holistic way. For example, if your employee hands the keys to the shop to some malicious party, all your fancy data at rest encryption and all the other buzzwords won't help you a bit. Everything in your enterprise and in your systems can be an attack surface, but it doesn't mean that you should be paranoid. We'll talk a lot more about this a little bit later. So let's go through the layers. The most outer layer you can see is the enterprise. So this is your processes, this is your people. You have to take care of them, and they will take care of your security. The next layer is the network layer. There are different kinds of networks that you have to worry about. Is the network private? Is it public? Or is it even virtual? And what does it mean if it's virtual? The next thing is the host. So the machine where your applications run on. These can be shared, these can be bare metal, or even they can be software as a service. So there is no concrete host, so you have to rely on a third party here. The next one is the application. And this is what this webinar is about, of course. We are like the expert in MQTT applications, mainly in brokers. And we will talk about that a lot, how to secure that. And the last one is you have to care about your data. Where is your data? What is your data? What kind of leakages are there possible? For example, backups is a keyword that comes to mind, or logging. And all of this is usually combined in this keyword pillars of IoT security. We chose 5 for this talk. Actually, if you look into the ISO specification for this, it's the ISO specification 27000. They talk about the first 3, confidentiality, integrity, and availability. And then there is a lot of more like authenticity, non-repudiation, accountability, reliability, and so on. And so we like standards here, especially open standards. And we will focus mainly on the first 3 now. The first one, confidentiality. What is it? We want information to be only available to authorized parties. So only people who should have the information should be able to get this. This is like the most important thing we care about. If you think about the big security screw-ups of our time, they are almost mostly always data breaches. We don't want our competitors to get our data because data is our advantage. We don't want to be liable for data loss, especially in the European Union. Legal punishments have become quite harsh in the last years, and this is good so, but we want to be compliant here. And we want to validate the trust placed in us by our customers. If we don't have the trust of our customers, they won't give us their money. It's just a natural reaction. And we don't want that to happen. So how can we do this? How can we achieve confidentiality? We have to think about trusted environments. Where is our application running? We have to think about transport encryption. How is data coming from place A to place B without being leaked? We have to think about mutual authentication. This means how can every participant in our data exchange be sure about who the other participant in our data exchange is? And if you get MQTT specific, we have to talk about subscriber authorization. So how does a trusted environment look like? First one, you have to run a broker and the devices in a trusted environment. This means in some kind of place where you can depend on the execution of your application. This can be, of course, in a cloud that you trust. This can be, of course, on premise if you have your server farm, but you need to have some kind of basis for this trust. And then brokers often work as interface between public and untrusted environments. So classical use case would be an open port for the internet, and then some backend systems that rely on the data delivered to these open ports. The last one is your devices. Devices you usually give out of hand. So never trust them unconditionally. Devices, if they are out of your hand, can be tampered with. We will talk a little bit about tamper protection later. But this is like the most important thing. Devices are out there and people will do stuff with them you are not planning for. Transport encryption. So we have this nice available protocol already that's called TLS. I hope everybody has heard of it. It is from the Internet of Humans, of people, but it can be used, and it is used quite successfully for the Internet of Things. And the really great thing is it doesn't concern us too much on the application layer, on the MQTT layer, because it's below that. For the experts among us, it's on OSI layer 4 protocol, so it's on the data transport layer. That's why it's called transport layer security. This has become the de facto standard for transport encryption, and it is well suitable for all TCP-based communication, which includes, of course, MQTT. TLS is a cryptographic protocol. It secures the communication and authenticates the channel between server and clients. So you have always this role, server and clients in TLS. Before a TLS session can start, the TLS handshake is done over this protocol, which guarantees these assurances. And the most important thing we care about is TLS secured communication can't be eavesdropped by anyone, and it prevents man-in-the-middle attacks. So it prevents somebody claiming they are, for example, an MQTT broker when they are not. But it has some challenges. And the most significant one in the IoT use case is the provisioning and revocation of certificates. So TLS relies on a certificate infrastructure. And when this certificate infrastructure has itself a breach, we get into trouble. And there are some ways how to do that. So the first one, of course, don't lose your certificates. But if this is not possible, you need a way to revoke certificates that are not trusted anymore. And this needs to be as soon as possible. And two ways for doing that is like certificate revocation lists, often called CRLs, or the OCSP, the Online Certificate Verification Protocol. And I would suggest using a system for that, like HashiCorp Vault or another enterprise-grade system that can be trusted with your certificate data. So best practices, always use transport encryption, use certificates from trusted certificate authorities. They are commercial ones, they are open source ones. And use the highest TLS version and secure Cipher Suites. I cannot stress this one enough. The more modern your TLS version is, the more secure you can feel in your communication. What is a secured Cipher Suite, you might ask? a secure Cipher Suite looks like this. So this is an example from the latest TLS specification 1.3. And generally, you can say the higher the number, the better. Use a proven algorithm like AES. This is like an advanced encryption standard from the American NIST Institute. And use safe modes. Generally, use the Golar counter mode. This is like the agreed on best mode right now. If you have to use TLS below 1.3, so 1.2 and even below that, be sure to look for this here, TLS over ECDHE, so Diffie-Hellman key exchange. This grants you something that's called perfect forward secrecy. It's a nice buzzword you can look up later. So let's have a quick look at how this looks. If the video starts, yes. So we first connect our client over the open network without TLS. And then you can see a malicious person could look at this traffic, look for your connect command, inspect it using some open available tools. And there you have your secret information that you don't want to have leaked, like username and password fields. So let's do the same thing over TLS. And you can see that you cannot see very much anymore. If you look at the TLS packet that was sent, we can know that it is an MQTT application layer protocol because it was on the secure MQTT port 8883, but we cannot see anything else anymore. And this is like the main thing we want to achieve with TLS. Nobody should see what we are talking about. If TLS is not available on your system, that is possible if it is really constrained or if the feasibility of public-private key infrastructure is not there. Then use payload encryption. This has, it can be much more lightweight because you can use symmetric encryption for this. But at least hash or encrypt passwords on your clients. And every client needs to have key and secret. But of course, it leaks metadata. So if you encrypt only the payload of your publishers, you will leak something like the topic or the quality of service level. Or if you use MQTT5, something like the response topic. And you could tell attackers about stuff you don't want them to know. So mutual authentication is the next one. This is can be as well provided by TLS. This is called TLS with client certificates. So the MQTT client, so the broker always needs to have a certificate, but the client can use a certificate as well. And then the authentication, the connection is mutually authenticated. These certificates are presented in the handshake, and the information there can be validated in a secure and cryptographic proven way. And afterwards, you can, of course, use application layer authentication and authorization. For example, use the information in the client, like the common name, and the client certificate, like the common name for permissions or whatever. The other way to do client authentication is through an external system. Usually use some information provided in the connect packet, like the username and password, and try to assign the client an identity with an identity and access management system. There are different ways to do that. Usually in the enterprise, you find something like LDAP or Active Directory, OAuth2 implementations, databases, access control list. There's really a plethora of systems available, and it depends on your use case and what already is in your enterprise that what you should use here. Important is here that not all brokers support pluggable authentication and authorization systems. So if you make the choice about your broker, choose one that can communicate with your system or the system that is best suited for your use case.
So first we start a broker with a very permissive authentication system. It allows any client to connect. And this is what we expect. Any client without any insured credentials can connect and can do stuff on the broker. After that, we plug our authentication system. And this is, in this case, an SQL database. And afterwards, you need to have pre-inserted credentials. And now we try the same again with the authentication system. The enterprise security extension with the SQL database in the background started. And now we can see that the connect fails. And so this is now the client has to authenticate against the broker for being able to successfully connect.
So what we have, the next step is subscriber authorization. So we are still talking about confidentiality, and the way we extract data from an MQTT system is through subscribing to a topic. So without authorization, every client is allowed to subscribe to all topics. And the important thing is here to restrict this. Clients should only get the data they are allowed to get. So your permission structure must match your topic structure. And to do this, it is usually a good idea to assign each and every client their own topic. And this is usually done through client identifiers, because the client identifier is unique in an MQTT system. You have to really be careful with wildcard subscriptions here. So if you use a wildcard subscription, this is like the hash symbol or a plus. This can go beyond the boundaries of a single topic. So if you assign wildcard subscriptions to a client, the client can maybe get more than it should get. So how can you do that? Your permissions should, of course, always include the exact topic we are talking about. MQTT is topic-based, and the topic is like the essential communication channel through the system. And it should encode the allowed operations. There are subscribe and publish, or both, if the system can do both, or should do both. Then the allowed quality of service. We have 0, 1, and 2, and all the combinations of that. And of course, there are many more specific operations that can be done, like retained messages, shared subscriptions, and other stuff. So how could this be done in an example? You could encode, for example, the topic as a string, because usually it is a string, and then have a Boolean flag for all the single features of MQTT. And every time the Boolean flag is true, the operation is allowed, and if it's false, it's not allowed. And then you can use a string for the shared group of your shared subscription.
So this is the subscribe authorization example. At the start, we have an allow all authorization. So it's very permissive. Every client is allowed to subscribe to every topic. And now we change this to an SQL database-backed authorization. Of course, we have to insert the right permissions here. So we just do that. And you can see there is an very specific permission. It's only allowed to subscribe to the client identifier of the client. So if the client tries to subscribe to the root wildcard, the hash symbol, it fails. And now it can only subscribe to a specific topic. This is the client identifier topic. And this ensures that there is no data leakage over root wildcard subscriptions.
So next thing we want to talk about is integrity. Integrity is the fact that information can only be put into the system or changed by authorized parties and no one else. So this is like the counterpart to confidentiality. Confidentiality is getting information out of the system. Integrity is getting information into the system. Why is this important? Devices make decisions based on data. You can, for example, use command and control topics to orchestrate your devices in the field and give them firmware updates or other stuff. Customers expect correct data. And this is like what they pay you for, that their data is the right data they are expecting. If you have like an IoT platform, you don't want to have false sensor data or something like this. And of course, deployment teams take decisions based on data. So they usually monitor some metrics. And if these metrics are tampered with, it can lead to taking false actions and compromising your system. So how is integrity achieved? Again, transport encryption, like data in transport, if this is tampered, the data at rest will be tampered with as well. We already talked about how to do that. Then again, mutual authentication. And you want to be sure whom we are talking to. We already talked about that as well. Now comes the counterpart to the subscriber authorization, the publisher authorization. So in contrast to subscriber authorization, publisher authentication pushes information into the system. Every publisher, by definition, pushes a piece of data into the system. And the very last thing to do here is broker and device access security. So if it is easy or trivial to access your broker on a like administrative level, your data is not secure, of course, because if you can tamper with the execution of your broker, the data delivered by the broker cannot be trusted anymore. So how can this be done? Publisher authorization usually is done via either block lists or whitelists. A block list is something where you deny the publishing client access to a specific topic. Everything that is not explicitly denied is allowed here. So you just pick single topics that you want to ban your publishers from publishing to or allow, or that you want to protect. This offers protection as long as all restrictions are known for all clients. Threats are only stopped here after the list has been updated. So if an attacker finds a new way around the system, you are open here for access. The counterpart to this is whitelisting. Everything that is not explicitly allowed is denied. This is the much more secure approach and much more restrictive approach. The downside is here you have a high maintenance effort, and you have to, before your system can be used, you have to change perhaps permissions. But access is only granted after the list has been updated. So the default state is a secure state. We would recommend going for that approach.
Now let's have a look at publish authorization. At the beginning, we have a client subscribed to a command and control topic, and a malicious client that sends a control message, shut down now, to this topic. And because we had no publish authorization in place, this message was delivered. Now we exchange this again with an SQL-backed authorization. And we can see here that the publish to the commands topic is false for this client. So it's not allowed to publish here. And as soon as it tries to, it gets an adversarial reaction from the broker and the message gets not delivered. So this keeps the integrity of our broker.
Let's talk about access security. This is like a very vast field. On one hand, you have to access security for the operating system of where your broker is running. This is usually a big IT system. On the other hand, you have access security for the devices. Like I told you before, devices you get out of hand, it's much more difficult to do this. So for the access security for the operating system, for the broker, we have a lot of tools. We can use basic prudence, like keeping our libraries and software updated. Usually, if there's a weakness or a vulnerability in a software piece, the vendor will issue a statement to that, and you can update and provide you with an update, and you can deploy that. This is, of course, important that this is done in a timely manner. Long update cycles are really dangerous here. Then every connection should at least pass one firewall. So this can be either a dedicated or integrated firewall, but it could even be provided by a cloud provider. Like in AWS, you have this security groups. This is in essence a firewall. Then, of course, disallow root access to the server your broker is running on, and use SSH keys for SSH. No password for SSH. It's much too easy to lose passwords. SSH keys are much easier to keep safe. Give your broker the right file permissions. Everything that starts with that ends with 2 zeros is usually a good idea here. So that only the user that the broker runs on can have access to the file system where the broker stores its data. Install intrusion detection and prevention systems. Usually this is either can be done on a network basis or on a host basis. And use all the security features that your usually Linux distribution provides, like C-Linux or there are more there. If you're using an intrusion detection and prevention system, be careful about overblocking. Why this is important, I will talk about later. Access security for devices is much more difficult. Some basic things to keep in mind here. Remove JTAG access. JTAG is good for debugging, but not good for the production. Use signed firmware. Everybody can take a look at how Samsung and Apple does this. They are really good at this. Secure access to certificates that you deploy on your devices, that they cannot be easily changed. And perhaps even deploy endpoint security on your devices. This is, of course, highly dependent on what your devices are. Perhaps on an Android or iOS device, you can deploy endpoint security. On an embedded controller, it will be really difficult. Okay, next one, we talk about availability. Why do we want to have availability? Availability is that the system can be accessed by authorized parties at any time. So anytime somebody wants to access and has the right to, they should be able to. Let's have a small excursion. A young software developer built a web app. He made it secure. He even went as far as to automatically generate a secure password for every deployment. Then he left the company. The second deployment, nobody could use it because nobody knew that a new password was generated. So it was a totally secure system, but completely useless. Nobody could connect to it. So what does it tell us? A non-available system has no value at all for us. Additionally, only use like system generated, only a system that is there can generate any value. Customers pay for the availability of systems. Availability can be achieved over many ways. The most important one, I would argue, is how to select the software stack you're using. The more reliable your software stack, the better your availability will be. The next one is incident management. How do your teams handle if something goes wrong? And on average, at some time, something will go wrong. And then what are the support systems you use? How is your choice here? How reliable are they? So everything around the broker and clients. First one, criteria for selecting the right MQTT broker. So your MQTT broker needs to be performant, scalable, and high available. It needs to have a track record and reputation of being a proven software, and the vendor backing it needs to have that as well. How long is the support you can have for your broker? So if your devices are planned for a lifetime of 5 years, it is no good if the support for your broker is only 1 year. You have to have compliance with the entire MQTT specifications, because otherwise you cannot migrate if you decide to change your broker's software. Monitoring of your broker and tracing of devices is important. You want to know what's going on in your system. And as this is a distributed system, this is really difficult without that. You have to have pluggable authentication and authorization systems. We talked about that one before. You have to have some form of denial of service attack protection. This can be via distributed denial of service or via normal denial of service. You have to have an overload protection. So what is when due to normal usage patterns, you have spikes. And if the spikes lead to the degradation of your service, you don't want to have that. It needs, of course, to support TLS. We talked about this as well. And what I would argue, you need to have a professional support here. So like a company or a vendor or some other instance that you can go to if you need help and if you need help fast.
Okay, now don't try this at home. We explicitly disable our overload protection. Never do this in production. And then start publishing with some clients. And as you can see, the broker gets overwhelmed pretty easily. Garbage collection times go up. And at some point, the broker will fail. now do the same thing with enabled overload protection and the exactly same setup. And as we can see, the broker state never reaches a critical, and after some time, the scenario gets finished successfully. And this is why we have overload protection, to handle such events.
Criteria for selecting the right MQTT client. It needs to be efficient, because it's usually run on constrained devices, and reliable. And it needs to implement the whole standard. Again, the reason for implementing the whole standard is perhaps you want to change later, and only if you already were on the standard, you can be sure that you are compatible in a later time. It needs to support all the security features of MQTT. So these are username, password, and in the MQTT tree standard, and of course, MQTT username, password, authentication data, authentication method, and the auth packet in the MQTT 5 standard. And then it has to have some longevity. You don't want to have to change it very fast if you don't need to. If you are like confident in the client software, you don't want to have to jump horse every time. Other systems are there. You need to have highly proven and production-grade third-party systems. They have to have a good track record. And of course, longevity counts for them as well. What is incident management? Incident management is that your company, your teams are ready to handle incidents. At some point, something will go wrong, and then you need to be ready for it. You have to make sure that there is a clear responsibility within your organization for incident management. Who is responsible? Who do I call? You need to have a defined process with a multi-tiered escalation. So perhaps a small incident only calls a deployment engineer. A larger incident might call a team lead, and the largest incident perhaps might even call a C-level executive. You need to have direct access to subject matter via expert or vendor support contracts. So you have to be able to rely on your partners on a business side. You have to do regular trainings and rehearsals, because only processes that you train your people in, they can perform in a stressful situation reliable. You have to have a high skill level of the responsible team. So you have to invest in them. Your people are like the most important capital you have. And of course, regular backups. No backups are no mercy, is like a flying word in the IT security community. What support systems are there? Support systems are like things like load balancers. They need to be reliable. They need to be able to work with MQTT. You need to have scalable infrastructure. That means if your application grows, you want to not have a hard time scaling the underlying hardware. You want to have automated monitoring and flexible log handling. Important here, logging is data. So keep in mind, this needs to be secure as well. Then you want to have alerting systems. If nobody notices that your system is down, you are not able to take any action. And you want to have some kind of IDS or IPS system, which has the right data source, like an access log, and must be IP-based, as MQTT is above the IP protocol here. Here's a big danger of the logout effect. So if your IDS system is too harsh in punishing connecting clients, you can lose availability again, because you deny access on like faulty rules. Finally, we have to look at the other pillars. The other pillars are highly use case specific, and we will not go into depth about them now. Just for mentioning them, authenticity. Information is associated with the source. This can be achieved in MQTT through payload signing, for example. So you deploy a private key on your devices, and they sign the payload before they publish it. So you can associate this piece of information with the sending client. Non-repudiation. Actions taken with a source after must be able to be associated with the source after the fact. Usually this is done through an audit log in an MQTT case. So a log that describes what action was taken on an administrative basis. Auditability. This is pretty much goes to the same. One thing is for the clients, the other is for generating like a paper trail that somebody can look at after the fact and like do a post-mortem if something happened, or even if you have like compliance requirements here, do it in an to have the auditors that come to your organization be able to show something. Yeah? They usually want to see what happens here. Is this all done well? Privacy. How not to leak personal data is here the question. This must be implemented in infrastructure. Again, I will talk about logs. Don't lose your logs. Usually an attacker can gain much information about logs. And if in the logs is something like client with the client ID of your family member connected at this time and disconnected this time, they can already start doing a profile. So what is the essence of this? Security is a key concern for any IoT application. HiveMQ implements the security features required for safe and secure enterprise IT and OT deployments. And now I will hand over again to Maggie for the rest of the presentation.
Yeah, thank you, Georg. Okay, so let's have a look about HiveMQ and how we do this. So security is a key concern for any IoT application, and so it is also to us. And HiveMQ implements the security features that are required for safe and secure enterprise IoT, IT and OT deployments, of course. So we have here an overview of the security architecture of HiveMQ. That picture is also here in a little bit smaller, so that you can see that in the slides later and compare both slides with each other. So what does HiveMQ provide you? First of all, of course, we have a pluggable authentication and authorization system. So that means you can connect any external system that you want here with HiveMQ. That is absolutely no problem. Of course, we also have a pre-built security extension that is our HiveMQ Enterprise Security Extension. I'll explain about that one in the next slide a little bit. And one thing that Georg mentioned, I think it was the first point in your part of the presentation, is the TLS secured communication. Of course, we have that. And here I can mention that we secure the communication between IoT devices and the MQTT broker, but also the communication between the cluster nodes in our MQTT broker. So here, every communication is secured. Of course, we also have an overload protection that protects all the whole cluster from being overloaded, and so a lot of more authentication and authorization systems and security systems are in HiveMQ. So to have a look into our HiveMQ Enterprise Security Security Extension, that is also a product from HiveMQ that is really made for central management for IoT device and HiveMQ Control Center authentication and authorization. Just to mention it here for those who are new to HiveMQ, the Control Center is the graphical user interface where you can do administrative actions and see what is going on your MQTT broker. So that is a useful tool if you deploy HiveMQ in production here to see what is going on. And you can also restrict the access to that tool using our Enterprise Security Extension. It easily integrates with multiple external authentication systems. So you just have to configure how the connection should look like and what you'd like to authenticate and how you want to do that. So that is pretty easy here. And of course, we also provide something like an access log where you can see which clients were allowed to connect and with which permissions. So if you want to have, or if you want to know more about our solutions here, then just reach out to us. We're really happy to help you in finding the perfect solution for you. Okay.
All right, I think now we're ready for questions. So there are a few questions. First of all, I will start the poll to not forget it. So the poll is now started. You should see it on your screen, and please give feedback. But now okay, let's go to the questions. So the first question is from Mark Fooley, who asks, do you have any examples where FOTA firmware over the air has been implemented using MQTT?
Yes, this is actually not so security related, but of course this can be done. A very nice pattern for this is to use a retained message to a known firmware update topic that a connecting client subscribes. The first thing, it connects to the broker and then gets back an a secure link where it can get an firmware update, for example, like an HTTPS link or something like this, or an or a file transfer server where you can get your firmware and then install it. So the usual pattern is here to get the information about where to get the firmware into the broker, and then for the client to fetch the firmware from an other system that is designed for transferring large amount of data.
Okay, so here we have another question by Antoine Fillon. Would there be a good source of information on MQTT TLS setups? Do the key certificates and sign-in authorities work the same as WebSockets, or do they need to be handled differently at all?
Yes, great question here. Of course, there's a great source like any MQTT topic. This is the HiveMQ webpage. So you go to hivemq.com and go to our blog, and there's a search button, and you can search for TLS there, and you will find a lot of information here and how to do secure deployments. And of course, you can use WebSocket Secure as well. Usually it's called an WSS for secure WebSockets.
Okay, thank you. So here we have another question by someone who wants to stay anonymous. He asked, how should the MQTT keeper life be determined, considering the trade-off of the IoT device's power consumption and firewall policy that blocks idle TCP connections?
Yes, this is very specific and great as well. So you already mentioned that there's like this parity. You don't want to have too many idle connections on your devices, and you don't want to waste too much money establishing handshakes. This is even more important if you do TLS, because you have at the beginning of the TLS connection this involved handshake. This has become better with TLS 1.3. So one suggestion would be to use TLS 1.3 as the handshake is faster. And even there's a second thing you can do. It's called TLS session resumption. If you use, for example, the HiveMQ client, it allows this feature. And so it remembers the TLS session state even after the connection drop, and can resume without doing the handshake. So this is like the way I would suggest to do this.
Okay, I think we have time for one more question. Let's have a look. So we have one by Shodari. Sorry for not pronouncing your name right. Publish, subscribe. Can we put this in terms of push, or is it different?
Okay, so publish, subscribe is basically you have two different communication partners. And one of the, or let's say the IoT, the MQTT client and the MQTT broker. So an MQTT client publishes its data via an MQTT publish to the broker. And clients that are interested in the information from this client subscribe to the topic the other client is publishing to. So publish, subscribe here works with topics. And so broker, the MQTT broker, then takes over the work to publish the data from this topic to all the clients that are interested in this topic.
All right. So now we have four questions that remain open. But as I told you in the beginning of the webinar, we will answer them on our community forum. I also pasted the link in the chat. There are also a few more other links. There is the link to our HiveMQ YouTube channel where you will find the video by tomorrow. There's also a link to our newsletter. You can subscribe and stay updated on upcoming webinars. And there's also already the link for our July webinar, which we will host together with Datadog, our new partner. Yeah, well, that's it. You will get a follow-up with all the information and the videos that unfortunately did not work today, but yeah, I hope you enjoyed the session, and thank you very much, Magi and Georg, for your presentation. So that's it. I hope we will see each other in July.